Alright, in this video I want to look at combining functions with addition, subtraction, multiplication, and division. This is from section 2.2. It's called the algebra of functions. So I've got two functions here, f of x and g of x, and I picked them so that their domains would be something kind of interesting so we could talk a little bit about domains here. So just to start out, the domain of f, we've got an x plus 6 inside the square root, which means that x plus 6 has to be greater than or equal to 0, or in other words, x has to be greater than or equal to negative 6. For g, the domain is we just can't have 0 in the denominator, which in this case means x cannot be 0. Alright, so our first function here is f plus g. Now the notation here, f plus g is actually the name of a new function. So we have the function name here of x, just like we have f of x, etc. But all this notation means is take f of x and take g of x and add them together. So this is super easy. If we have two equations, if I want the function f plus g, all I'm going to do is take the equation for f and take the equation for g and add them together. Now in this case, if you wanted to, you could find a common denominator and put these together as one fraction, but that's not really necessary, so I'll just leave it as is. Now the domain, when we put these together, the domain has to be, well, whatever x value we use, it has to be in the domain of f, otherwise we wouldn't be able to compute that part. And it also has to be in the domain of g, otherwise we wouldn't be able to compute that part. So when you combine two functions, the domain is just the combination of the two domains from the individual pieces. If I sketch this on a number line here, we've got domain for f is negative 6, everything there and above, but then g says we have to leave out 0. So the new domain is going to be negative 6 and above, but leaving 0 out, right? There would be the interval notation for that. I can do the same thing for f minus g. That one looks basically exactly the same, except there would just be a minus in place of all of those pluses. The domain of f minus g is also the same. I can do f times g. So here I'm doing f times g of x. And this is just the same idea. I'm just going to take f of x and g of x and multiply them together. So here this would be root x plus 6 times 1 over x, or if I wanted to simplify that a little bit, that would just be root x plus 6 times 1 over x. The domain here as well is just, well, whatever the domain of f was and whatever the domain of g was, as long as we can compute both of those, we can compute the product. Here I have f times f, that would be f times itself. So f of x is f of x times f of x. In this case, since we're multiplying the square root times itself, we could multiply those together and get x plus 6. And that's not too surprising, but what I do want to comment on is that the domain here is still the domain of f, right? It's still only numbers greater than or equal to negative 6. In order to form this function, we really have to be able to compute f and then just multiply it times itself. So even though x plus 6 on its own, you'd be able to plug in anything, for this product, the domain is only the domain of f. Last piece here, when we divide functions, we do have to mess with the domains a little bit. So g divided by f of x. Again, this is just what you would expect. We're taking the g function and we're dividing by the f function. So here that would be 1 over x divided by root x plus 6. This one you can do a little bit of simplifying. So this is 1 over x times the reciprocal, or 1 over root x plus 6, or as a single fraction, x times root x plus 6 in the denominator. Here, The domain has to have the domain of f, right? Because whatever we pick has to be able to plug into root x plus 6. And it also has to have the domain of g, that would be this guy. And f cannot equal 0. Because we're doing division, we now have to take a look and make sure that whatever we're putting in the denominator, in this case the root x plus 6, that can't be 0. So if I look at where f equals 0, that would be where root x plus 6 equals 0. That's when x equals negative 6. This means that we have to leave this out. So the domain now looks almost the same as before. The only difference is before we were allowing negative 6 and now we are not allowing it. Same thing with f divided by g. I won't go through this one, but again, the domain of this one would be whatever the domain of f is plus whatever the domain of g is, plus, in this case, g cannot equal 0 in order to form that division. And that's it.